Welcome. Today we'll discuss about transaction management in DBMS. So what is transaction? So transaction is a program including the collection of database operation executed as a logical unit of data processing, or we can simply say that transaction is a logical unit. Okay, transaction is a logical unit of work which includes or which is interacting with the database. Okay, so it is a logical unit. It is a logical unit of work which is going to interact with the database and potentially altering the database. Okay, so we can have a sequence of one or more database operation in the transactions. It can be like a read or write or insert, delete, any operation. So it can be sequence of one or more operations. That is what it is given. So the sequence of operation can be one or more, and it can be like insert, delete, update, or retrieve the data. So transaction, it is a logical unit of work which is going to interact with the database by potentially altering the data, and this transaction involves a reading or writing operation or insert, delete, update, retrieve data, any of these operations. Okay, and it is an atomic process, that is either the operation is completely performed or it is not performed at all. And if the transaction is only data retrieval, it is called as read-only transaction. Okay, so the transaction before and after the transaction execution, okay, so it should maintain some data integrity, it should maintain integrity, it should maintain consistency, and also it should be reliable. So this has all been addressed by ACID property. Okay, so we'll discuss that ACID property further. Before going into that, I said you this transaction might involve a sequence of operations, right? Sequence of one or more operations. So like insertion, deletion, updation, retrieving, reading, writing, anything. So we'll see that operations. So we have operations like this. So begin operation. So the begin transaction, it is a marker, okay? So which is going to specify the start of the execution. And the same way, end transaction is a marker that specifies the end of the transaction. And we'll have like a read or a write. And we can even have the commit transaction or rollback transaction. So commit transaction, it is only when the operation is successfully completed. So that time we'll have this commit transaction. Okay, so we can have this commit transaction and rollback transaction. So when the transaction is successfully completed, then we'll go for this commit transaction. And when the transaction is aborted and we have to go for the previous state or to the original state, then we'll go for this rollback transactions. So let us see for this read and write example. So read operation is used to read the value of x from the database, and it is storing in the memory. Same way write, it is used to write the value back to the database from the buffer. So here they have given one example. Let us see that. For example, let us assume that before transaction the value of x is 4000. So now here the first statement, it is reading the value r of x. So what is the value of x? It is 4000. So from the database, it is reading the value, read the value from the database, and it is storing in the buffer. So it is reading as 4000 and storing in the buffer as x is equal to 4000 in the buffer, right? And the next transaction, second transaction here is x minus 500. So it is decreasing the value of x by 500. So now what will be the value which is in the buffer? So 4000 minus 500 will be 3500. So that value of x will be stored in the buffer now. And the third operation is write operation. So now the buffer, from what will be the value of x now? It will be 3500. So now it is going to write back to the database from the buffer. It is going to write back to the database as x is 3500. Okay. So now x value is 3500. Okay. So for this we have to maintain some ACID property. That is what we are going to discuss now. So to maintain the data integrity, consistency and reliability before and after the transaction, it has to maintain this ACID properties. So that is what we are going to discuss now. So what is ACID? So A stands for atomicity, C stands for consistency, I for isolation and D for durability. So that is ACID property. So we will discuss one by one. So what is atomicity? Atomicity means this atomicity will guarantee that the transaction is either executed or not executed. So either executed or not executed. So it means that either all are executed or none of that is executed. So that is atomicity. Okay, it cannot be partially executed. Right, and the responsibility, who's going to hold this, who's going to look after that, whether the transaction is completely executed or it is not at all executed, it is the work of the transaction control manager. Okay, it is the work of transaction control manager. Okay, so who's going to hold the responsibility, who's going to ensure the atomicity of transaction is the responsibility of transaction control manager. Who is the responsible person for this is transaction control manager. So transaction control manager is responsible for the atomicity. Okay, so he is going to take the responsibility for atomicity. And next property is the consistency property. So what is consistency? It is going to ensure that the transaction will bring the database from one valid state to the another valid state. Okay, so without disturbing or without violating the constraints, the database constraints. Okay, so it has to ensure that the transaction will bring from the database from one valid state to the another valid state. So that is consistency. Okay, if you see here, it ensures bringing the database from one consistent state to the another consistent state. Okay, so that is your consistency. Okay, but it should not affect the database constraint. It should not violate the database constraints. Okay, so it has to maintain the integrity of constraints during the transaction. Okay, and the database should remain in valid state before and after the transaction also. It should be in the valid state. And who holds the responsibilities? Application programmer holds the responsibility. So application programmer holds the responsibility for this consistency. And next is the isolation. So isolation ensures that the concurrent transaction do not interfere with each other. Okay, so the isolation ensures that transaction is isolated from other transaction. It means that, so even if there is a transaction running parallelly, so it is not aware of that transaction which is running parallelly. So while running each transaction, it will behave like it is the only one executed. Okay, it will not be known of the other transaction which is running parallelly. Only once it is committed, only then it will be visible to the other state or other transaction. Okay, so that is isolation. So isolation will ensure that concurrent transaction happens without interfering each other. Okay, so here each transaction will operate as if it is the only one running. It will not be aware of the transaction which is running parallelly. When it will know, only when the transaction is committed to the memory, that transaction which was running parallelly will be visible to the another one. So that is isolation. And who holds the responsibility of isolation is concurrency control manager. Okay, so who is responsible for that? Concurrency control manager is responsible for isolation. And next is the durability. So what is durability? So once transaction is committed, it will remain in the same state and it will be stored to the disk, and it will survive the system failure. That is the durability. Okay, it will guarantee that one transaction is committed and its changes is permanently stored in the disk, and it will survive the system failure. Okay, it will not be lost. Okay, it will be stored in the disk. Even if there is an error or even if there is a power loss, once it is committed, it will be stored in the disk. So that is your durability. And who holds responsibility for this durability is recovery manager. So who holds responsibility for this is a recovery manager. So atomicity is taken care by transaction control manager, consistency is taken care by application programmer, isolation is taken care by concurrency control manager, and durability is taken care by recovery manager. Okay, so that is what given here in detail. Okay, same thing, the responsibility for maintaining those property. So for atomicity it is transaction manager, consistency it is the programmer, isolation it is concurrency control manager, and for durability it is the recovery manager. And what is the advantage of this ACID property? By having this ACID property, your data is consistent and it is maintaining the integrity and will have concurrency control. So it will not be able to interfere with each other, right, when the transaction is running. And even when the transaction is committed, it will be stored in the disk. So recovery is possible even if there is a system loss or some error in the process. So this is the advantage. And what is the disadvantage? And it can this ACID property disadvantages, it can cause performance overhead. So additional processing is required for maintaining that consistency and integrity. So that is one disadvantage. So performance overhead. So scalability issue will be there. That is large for your distributed system because multiple transactions can occur simultaneously. And complexity, implementing this ACID property will increase the complexity of a system. And also why? Because we have to ensure the data integrity, accuracy, reliability, and we have to maintain all those things, uh, right? So ACID property can cause the performance and scalability issues. Therefore it is important to balance all this ACID property against the specific needs and requirement of the system. So next we'll move on to the transaction states. So we have different transaction states. So active state, partially committed state, failed state, aborted state, and terminated state. So what is this transaction state? It is the different phases of transaction it is going through in your database system. Excuse me. So this will help in tracking the process and overcoming the or for the outcome of the transaction, by which it is maintaining the consistency and the integrity. So we'll see one by one. So active state. So active state is an initial state. Okay. So it is an initial state. So while executing, it will be in active state, and the transaction details will be stored in the buffer. Okay. So here in this, it is the initial state. So while executing this initial state, it will be temporarily stored in a buffer. So what will be executing? So either we can have read operation, write operation, or any of these operation will be executing. So that is in the initial stage, and it will be stored in the buffer. And next is your partially committed. So this one is after the final statement has been executed. So active state is the initial state, and partially committed state is a final state. Okay, has been but still this is also in the buffer only. Active state is also in the buffer, and partially committed state is also in the buffer. Okay, and failed state. So after discovering that it has some abnormal issues and the normal execution is not possible, that time it can go to the failure state. So after completing the final execution also, it can go to the failure state. In the beginning of the execution also, it can go to the failure state. Okay, when there is no possibility of further executing it, so it might go to the failed state. And after it is going to the failed state, it has to roll back to the original state or a prior state. Changes must be undone. Okay, so that is your aborted state. So after the transaction is rolled back, the database changes must be undone or it must be restored to its prior state of transaction. So that is aborted state. So this aborted state, we can have two types. Either we can, after abortion, we can restart the transaction or we can kill the transaction. So this is possible. Either we can restart the transaction or we can kill the transaction. Okay. So this is the case when it is failed and then it is rolled back and it is aborted. So after aborted, it will be terminated. It will end the transaction. Okay. So if it is not failed, if it is doing the execution, if it is completing the execution successfully, and then the value will be stored from the buffer to the disk. So that is committed. After the successful completion of the transaction, the database will be stored in the disk. So that is your committed state. So after completion of such committed state also, it can terminate the transaction. So terminating the transaction is to end the cycle. Okay, so you understood what are these states. Active state, it is the initial state and it is stored in the buffer, and next is the partially committed state, that is the final statement, but still it is in the buffer. And committed state, after completion, successful completion of this final statement, it is the value is being stored in the disk now, from the buffer to disk. So it is a committed. After completing all this, then it can terminate. Or suppose if there is a failure while it is executing, or beginning of the process only there is a failure, it will go to the failed state, and after failed state it has to roll back. Okay, a rollback, so that is aborted. To it has to come to the original state or this prior state. So that is aborted. After abortion, again it can terminate to end the cycle. So this aborted state, after abortion, either we can restart the transaction or we can kill the transaction by terminating it. So these are the different transactions in the DBMS. Okay, so that is what given here. Okay. So one example here I have taken. So let us say there is a transferring money from account A to B. Okay. So it is read A. Transaction is reading the value of A. Right? And executing A is equal to A minus 5,000. So 4,000 minus 500, 3,000. It is in the active state. Okay. It is executing. And partially committed, after the complete, after reading it is writing the value of A, updating the value of A and B. So it is a partially committed, but still it is in the buffer. After completing this right now, it is saying that it is successfully completed, and it is updating the balance of A and B. So that is committed state. So here it is stored in the buffer. This value of A and this B, it is stored in the disk. So here this value of A is stored in the buffer, and here this value was stored in the buffer, whereas here it is stored in the disk. And failed state, if there is some error in the execution, the transaction can no longer proceed. So then it is going to the failed state. So error may be because of system crash, or because of violating the constraints, integrity constraint, or it can be because of deadlock, or it can be because of error. So your write operation, updating the balance, becomes failed due to some system crash or something like that. So the transaction T1 will move to the failed state. And next is the abort. After fail state, it has to abort it, so it has to come back to the original state. So that is, it should roll back, it has to do undo. Now the database will be stored in the prior state. Okay, so that is your aborted. So aborted has two possibility. After abortion, it can either restart the transaction or it can kill the transaction. Kill the transaction, permanently terminate it, or restart the transaction means, so it will retry it. After this abortion, it can go for termination. Either after abortion it can go for termination, or after successfully completion also it can go for termination. So it is either successfully completed or completely aborted. So the transaction T1 will enter the terminated state. So this is the example for the transaction states. Thank you.